Right, now I've got my drive mount plates in, we can fill him up with parts. And the first thing I'm going to do is I'm going to put my bearings in there. And I should point out that my bearing models are wrong, because the way I want to do this, to make the whole thing easier, is when I get these plates, the holes aren't going to be perfect. I'm not going to be able to fit the bearings in there, because the water jet cutting is going to put a taper on the plate. So I'm going to have to get out the die grinder and grind out the holes until the bearings fit. Which probably means, knowing the way I tend to use tools, the bearings are going to be sloppy and fall out. And the best way I can think of making sure the bearings do not fall out while the robot is operating is to use flanged bearings, which took me a long time to find on eBay. These things here, flanged bearings. So, do I have a better picture? There we go. Oh, there we go, there's a good one. So they machined the bearings with a flange on the outside. And I have been searching all over the internet for these little bad boys, and from what I can tell, they're only made in China. And I can't find bugger all dimensions on these things, or standards, or anything. It's like it's a Chinese invention. But I can buy a packet of 10 of them for $24 with postage, which is $2.40 a bearing, $2.50 a bearing, which isn't very expensive, considering that most shops in Australia want you to pay $10 for a bearing without any flanges on it. But also, because I can't find dimensions, I don't know how thick the flange is, which means on my model I'm going to have to do some guessing, because I'm too poor to actually buy bearings at the moment. But so what I'm going to do is I'm going to insert these things, and then select a bearing, insert it onto the inside edge, but make it proud by 2mm. Proud, that wasn't proud. Proud by 2. No, what am I doing? There we go. Proud by 2mm on the inside, which is me pretending there's a flange on there. And the whole idea is I put the bearings with the flanges on the inside of the welded chassis, put the gears on in here, and then put washers or other spaces inside so that the flanges will end up pushing out. So the only way for the bearings to come out of the robot is for them to fall inwards, which means it has to push the other side outwards. And it means that no matter how sloppy I grind out my holes, the bearings will not fall out. Does that make sense? Makes sense to me. Okay, well, I'm just going to go through and insert all these other 8 bearings, so you can enjoy fast forwarding that. There we go. And I've got bearings on all my axles. And once all their grub screws and everything are holding in, the axles won't fall out, bearings won't fall out, and it'll all be nice and pretty. And that's the reason why I use 6mm steel plate on my drive mounts, so the 6mm plate the bearings sit in nicely on there. This one a bit too small. They may actually be 1mm flanges, I don't know yet, but that's how I'm just modelling at the moment. Once I get some money and a job, then I can buy some bearings and do some measurements and make sure it's all correct before I actually get steel cut. Now what am I going to do? I am going to copy the motor out of my Fury model. I never actually read what this says. I just always hit OK. How slack is that? Oh, it's got all these insertion points on it. Turn off 2D sketches in here. All those insertion points disappear. There you go. Beautiful. And we'll just constrain these motors onto the frame. Actually, we'll just notice something. Because these bearings and axles here, they should be motors should mount that way. That way this little cutout on the side of the motors would allow clearance around the bearings, which figures out quite nicely, but it means the wires point up or down. So they're going to have a nice curve in there to get around the top plate and bottom plates. I'm also going to have to make some holes in the side frame here so the screwdriver can pass through to put in these screws to make it easier to assemble. That's no biggie, we can do that later when we tidy up the model. We'll do the finish modelling at first. I'm not going to bother putting the mounting screws on. They just take too much effort. And you slow down your computer. So we're going to put mounting screws on. I know they're there, you know they're there. Computer doesn't need to. Now we'll do some gears. Fun part. Go to design, and there is a spur gear generator under power transmission. So we can actually do worm gears, bevel gears, bearings, belts, sprockets and chains, cams, O-rings, all sorts of fun stuff. But here we'll just use gears. So we've got a mod 1 gear, we've got 50 teeth on the first one, 15 teeth on the second. Face width is 15 millimeters. Just double check that. Yep, 15 millimeters. All good. So we select a cylindrical face, the axle, start plane, do the inside of the bearing, and the second one we do a cylindrical face. More beautiful. We hit OK. You want to make sure you got your axles the right distance, otherwise the trucks are wobbly. But because I did all my calculations in previous videos, we know that they're correct. And we hit OK. Creates new parts and sub-assemblies. Thinks for a minute. And there's my brand new gears. Now let's put it flush up against the bearing, which I don't really want. So we'll go back to here, to the constraints, edit it, and put a 1mm gap in there. So now the axle gear isn't flush with the bearing. Also, if you look at the models, if you actually open it, the model it created for the gears is solid. Inventor just does the rough extrusion for the outside and expects you to do the rest of the work. It is cool model. We'll just close that. Do you want to save it? No. So what I'm going to do is I'm going to change my selection here, component priority, to single part. So that way instead of selecting the whole assembly or sub-assembly, I can select each gear individually. Select the first one, click edit. And we can actually edit that model in the assembly. I only do that with gears. I don't do it with everything else. You probably can, create a hole here that's central to that, but then we do that with the skeleton anyway. So, but I modify my gears here just because I can. So, I want to create a new sketch there. New sketch. There we go. Now I could project through the size of the axle and have it automatically do the whole size of the axle, but I don't trust it. I like to do it all manually when I edit things this way. So I'm just going to put a 12mm circle in there, and then just extrude that all the way through. So now my gear has a hole in it. And yeah, I could make it do it to the size of the axle, but then yeah, it doesn't always update. It might chuck a wobbly if things move too much. If I just do it manually, it's alright. Anyway, now I've got to do the hub thingy on the side of it. Just go back to the website for the gears. It says the hub diameter is 30mm. Yep, 30mm, this one here. So we'll do a new sketch for another circle. Make that 30. Extrude it out the side. 10mm. And finish edit. And now my gears are a lot more realistic and a lot more heavy. And I should do the same thing for the front gear, which I might fast forward. You don't need to watch it twice. Yep. And there's my second stage gears on that side of the robot. And the fun part is, if we go back to select component, select the sub-assembly for those gears, copy, paste, and there we go, it's already done for us. Magic. And then we can just constrain that into the other side of the robot. There we go, second stage gears. Now all I have to do is the first stage gears. You want to watch that in fast motion? Fast forward. Alright, and that's my drive setup done. 10:1 gear reduction into 100mm wheels using NTM 4238 motors. Custom gearbox. Flanged bearings. All pretty. It should be easy to make. A little bit expensive though. A little bit expensive. Oh well, I like it.